I'm glaring. I'm glaring. Oh, what are we doing? We're rationalizing roots with higher order indexes. Yeah, I hope I can find my way to the first example. Yeah, this guy. All right, what am I doing? I'm looking at, wait for it, wait for it. That's the third root. I got a 75 in there. 75 times what is 375? Is it 6? It's not 6. Is it 5? It's not 5. Is it 4? It's not 4. It's I don't know. Oh God, 5. Yeah, 5 times 5 is 25. Carry a 2, that's 5 times 7 is perfect. Divided by 4. Now I'm gonna finish up because the third root of 75 is 5, and then I have a 5 root 4 inside. But the thing about this example is we're rationalizing denominators, and I see that 4 is 2 times 2. How many 2's do I need to get 1 out? I need 3 2's. So what do I need to do? I need to multiply by an additional 2. First, let me rewrite this as 5 times the third root of 5 divided by the third root of 2. Why'd I do that? Just to make it look nicer. Whoa. If Elvis was a 4. Sure. So then I need to multiply this by an additional third root of 2. Third root of 2. And you ask, why do you do that? Because then I'm going to have 5 times the third root of, wait for it, 10, divided by the third root of 8. Great. Wait. 8 does have that third root. And that's what I'm trying to get at. 5 times the third root of 10 divided by a deuce. And we no longer have a radical denominator. Yeah, I'm on up over here. Like in the previous example, previously in math class, we simplified that radical first. And now, let's simplify that radical now. So that's a minus because it's on the outside. We don't worry. So then that's the third root of 7p. Now there's no 3 factors in there, so that's divided by the third root of r to the 10. Then I simplify that root, and that's minus the third root of 7p, and then how many r's do we take out of there? There's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. R. Or similarly, we could have used division and seen that it was 3, remainder 1. All right, so I get to pull out 3. Boom. And what remains? Just 1 r. And then that's the third root in here, but what are we trying to do? We're trying to rationalize that denominator. I have 1. How many do I need to get 1 out of a third root? I need 2 more r's. So then I'm looking at the third root of r squared and the third root of r squared. Up at the top, I'm going to combine those roots because a product of the roots is the root of the product. Yeah, so that's minus the third root of 7p r squared divided by, wait for it, that's r to the third times the third root of r to the third. Finish him. Yeah, finish him! Because r times r squared is r to the third. That's why I have a minus third root of 7p r squared over. Now 1r comes out of there. Nothing left in the root, and you have r to the fourth, because r to the third times r is r to the fourth, and that's r. Example of rationalizing the denominators, but one more. What about something like this? Oh no! So then that's the fourth root of 16 divided by the fourth root of AB. That gonna be deuces over the fourth root of AB. But wait, there's more. I have the fourth root. Huh, did I go too fast in saying that's 2 times 2 times 2 times 2? I don't think so. So then I need to multiply this guy, because I'm rationalizing that denominator. That I need to multiply that by the fourth root of, now I have one A and one B. How many more A's do I need to get 4? I need 3. And how many more B's do I need? I need 3. And I can't just multiply the denominator without also multiplying the numerator. That's the fourth root of a to the third b to the third. Because what is that? That's the magic one. If I can multiply once, then I can multiply twice. Yeah, so sure. That's 2 times the fourth root of a to the third b to the third. And I heard that's all over the fourth root of a to the fourth, because I got the same base and I'm multiplying. What am I going to do to their exponents? Add them. So then I add them, and then that's a b to the fourth, but the fourth root of those guys, assume variables are positive, because the 4s, because those are even, it should be the absolute value, but I'm sure your book says assume the variables are positive. So then that's 2 times the fourth root of a to the third b to the third, and I heard it's all over ab, and it's all over but the box and flour.
We're sorry, the number you have dialed is not in service at this time.